Hello. In this video we will be going over the Network and Fundamentals, which is Domain 1 of the Network Plus exam. In this video specifically, we will be reviewing the OSI layers and the different encapsulation concepts. The OSI model consists of 7 different layers. Layer 1 being physical, Layer 2 data link, Layer 3 network, Layer 4 transport, Layer 5 is session, Layer 6 presentation, and Layer 7 application. The first layer of the OSI model is the physical layer. This layer includes the physical and electrical medium involved in the data transfer between two nodes. This layer is also responsible for the transmission of the raw data, which is simply ones and zeros, with 1 standing for on and 0 standing for off. Examples of Layer 1 technology include hubs, repeaters, cables, fibers, and wireless. The second layer of the OSI model is the data link layer. The data link layer provides node-to-node data transfer between two directly connected nodes and also handles the error correction from the physical layer. The data link layer also takes packets from the network layer and breaks them into smaller pieces called frames. There are 2 sublayers to the data link layer. The first one is the MAC layer, which stands for Medium Access Control. And this sublayer uses MAC addresses to connect the devices, and it also defines permissions to transmit and receive the data. The second layer is the LLC layer, which stands for Logical Link Control. And that sublayer identifies network protocols, performs error checking, and also synchronizes the frames. Examples of Layer 2 technologies include network switches, modems, NICs, which are network interface cards, and also bridges. The third layer of the OSI model is the network layer. The network layer has 3 main functions. First, it is responsible for facilitating data transfer between 2 separate networks. Secondly, it will also break up segments from the transport layer, also known as Layer 4, into smaller units called packets. Lastly, it will also find the best physical path for that data to reach the destination, and this is also known as routing. Examples of Layer 3 technologies include physical devices such as routers and Layer 3 switches, but also technologies that fall under Layer 3 are the protocols IP, which is Internet Protocol, and ICMP, which is Internet Control Message Protocol. The fourth layer of the OSI model is the transport layer. The transport layer is responsible for coordinating the data transfer between end systems and hosts. The transport layer takes data transferred in the session layer and it will break it down into segments on the transmitting end. The transport layer on the receiving end is then responsible for reassembling those segments into data that the session layer can understand. The transport layer also carries out flow control, which is simply making sure that the sending end and the receiving end confirm on a data rate that works for both. It also performs error control, which is simply checking to make sure that the data received was received correctly. And if it was not received correctly, then it will request for that data to be sent again. Examples of Layer 4 technology include the 2 most common protocols, TCP and UDP. TCP stands for Transmission Control Protocol, and it is also a connection-oriented protocol, which means that it tries to maintain a connection between the 2 hosts. UDP stands for User Datagram Protocol, and it is a connection-less-oriented protocol. And what that means is it's more of a fire and forget rather than confirming that the receiving end actually got that data. The 5th layer of the OSI model is the session layer. The session layer is responsible for opening sessions, ensuring they remain open and functional while data is being transferred, and then closing them when the communication ends. The session layer is also able to set checkpoints during a data transfer, so if that session happens to be interrupted or dropped, then the devices can resume the data transfer from the last checkpoint when that connection reestablishes. Some examples of Layer 5 technologies include Network Basic Input-Output System, which is NetBIOS, Layer 2 Tunneling Protocol, which is L2TP, and Point-to-Point Tunneling Protocol, which is PPTP. The sixth layer of the OSI model is the presentation layer. The presentation layer is pretty straightforward in that it only prepares data for the application layer. It defines how two devices should encode, encrypt, and compress the data so it is sent and received correctly and can be correctly read at the application layer. Examples of Layer 6 technology include SSL, which is the secure socket layer used usually with HTTP. The seventh and last layer of the OSI model is the application layer. The application layer is used by end-user software such as web browsers and email clients. It provides protocols that allow software to send and receive information and present meaningful data to the users. The client software applications are not part of the application layer. It's just the underlying protocols that they utilize that would be considered part of the application layer. Some examples of Layer 7 technology include Hypertext Transfer Protocol, which is HTTP, Simple Mail Transfer Protocol, SMTP, File Transfer Protocol, FTP, and Trivial File Transfer Protocol, TFTP. Now that we covered the different layers of the OSI model, we can now talk about how data gets encapsulated as it goes through the different layers of the OSI model. Encapsulation that happens at layers 5, 6, and 7 is considered to be the payload. Usually when it comes to encapsulation, layers 5, 6, and 7 can be combined together. At this level, it is usually encapsulated based upon the software and the protocols that were being used at the time of encapsulation at the application layer. The encapsulated total data is considered to be the payload. However, payload and data can be used interchangeably as you move further in the encapsulation process. At the bottom here, I am going to be using this example over the next couple of layers to show how encapsulation actually builds upon a data request or data being sent. So for this example, I have an HTML web request for my web page, and it is being encapsulated in HTTP, which is the application layer protocol. When the payload hits layer 4, it will then either be encapsulated in a TCP or UDP header, and that will depend on which protocol is being used to send this data. In this case, for TCP header, you will see a picture showing the TCP header on the right and kind of the outline of how the fields are designated inside of that header, and on the left is a list of fields. You will want to know what each of these fields do within the header for the test, but the main thing to remember when you hear TCP header is that it is dealing with ports and TCP flags. At the bottom you will see that HTTP is being encapsulated by the TCP header, in this case for our example, and it will actually wrap around that payload. So now the HTTP and HTML request is considered the payload for the TCP header. Here's a picture of each of the TCP flags and what bit will then need to be turned on inside of that TCP header for that flag to be enabled. And also, when it comes to the list of the TCP flags, I would suggest knowing what the bottom 6, urge, ACK, push, reset, SYN, and FIN, you will need to know them for the test. If the data being transferred is going to be sent through a UDP port, then it will be encapsulated by a UDP header. The UDP header simply consists of the source and destination port, the UDP length, and the UDP checksum. Here is a picture of the UDP header showing how many bytes each of those consists of. When the payload reaches layer 3, it will then be encapsulated by the IP header. On the left, there is a list of the fields within the IP header and what those fields represent. The main ones that I would suggest to know are the time to live, TTL, and what that actually stands for, as well as source IP and dest IP and the fact that the IP address is assigned at the IP level. On the right, there is a picture of the IP header and where those fields actually sit within that header. It also shows how long each field is in bytes. For instance, TTL is 8 bytes long, and source IP and dest IP are each 32 bytes long. Continuing with our example, at the bottom you will see that the IP header then encapsulates the TCP segment, and it now is represented as a packet. When the payload reaches layer 2, it will then be encapsulated by the Ethernet frame. At the top, there is a picture showing what fields are within the Ethernet frame and how they are laid out. The biggest thing to know about encapsulation at layer 2 is that this is when the source and destination MAC addresses get assigned to the frame. Following our example, at the bottom you will see that now the Ethernet frame encapsulates the complete payload of the other layers, and it is now ready to be sent out on the wire. Decapsulation is the same process, just simply in the reverse order. So if we were sending an HTML web request to a website for our previous encapsulation example, this would represent what the web server will respond with, and how our computer would handle it once we receive it. Once we receive it, our computer would check to make sure that the destination MAC address in the Ethernet frame matches our MAC address to know that this frame is designated for us. Once that happens, it would strip the frame off and then send it up to layer 3 for the IP to be read at the packet level. It would then check the destination IP address, make sure that it matches our IP address to make sure that we were the ones to receive the packet, in which case then we would decapsulate the IP packet off and remain with the TCP segment. The TCP segment would reach layer 4, make sure that this data is in the order that it is supposed to be in which case it would then remove that segment and send the HTTP payload data up to layer 7. Once the payload reaches layer 7, the web browser will then take that data and produce the web response in the browser. Thanks for watching, and stay tuned for more videos regarding the Network Plus certification exam.